1.78 grams of HgI2. HgI2 is mercury 2 iodide or mercuric iodide. It's an ionic compound. Mercuric iodide is formed. Find the initial amount of potassium iodide in the reactants. Okay, so when you're doing stoichiometry, what I always recommend is write out the reaction first. So Ki, potassium iodide, plus mercury 2 nitrate, or mercuric nitrate. What kind of reaction is this, by the way? This will be a double replacement. We have an ionic with another ion. So we'll go potassium nitrate, they switch ions, remember, and mercuric iodide. So there's my double replacement reaction. As time goes on, try to get more familiar with writing these, so you'll need to do this on the exam. Now, underneath, I write down what I'm given. So I'm given 1.78 grams of this, and I write down what I want. I want the initial amount or mass of potassium iodide. Okay? So I'm going to start with what I have and go to what I know. Let me explain that in two ways. First, visually, I'm going to move this for a moment. Visually, what I'm going to do, I have the mass of the products. I'm going to convert that to moles. I'm going to use a molar ratio to go to moles of the reactant, and I'm going to use the molar mass to go to mass. So I'm going to go in this path right here. Okay? That's the global kind of picture. Another way to explain what I'm going to do here is when you're doing stoichiometry, and I'll kind of do this as scratch right here in brown. Step one is convert given to moles. So whatever units you're given, go to moles. Step two, you're always going to use a molar ratio, which you saw on the Molar Express. And then step three, convert to requested variable. Okay? So really in stoichiometry, you're always going to have these three steps. Whether you visualize this through the Molar Express or you like to look at these three steps, it doesn't matter. You're always going to convert to moles, use the molar ratio, then to convert to what you're asked for. So let's try it with our problem right here. Step one, we're going to start with what I have, 1.78 grams of the mercuric iodide, HgI2. Okay, then molar ratio to get the moles. Let's go to moles, and from the periodic table it's 454.39 grams. Now I'm at moles, I've done step one. Now I'm going to use a molar ratio. What do I need to do before I do that though? Oh shoot, I better balance this craziness. I think we can do with 2 iodines there and 2 of those. Okay, so there's 2 moles of what I want on top, Ki. The 2 comes from the coefficient 2 for every 1 mole of the HgI2, because there's 1 for the coefficient of HgI2. Now I've used my molar ratio. My final step is to convert to the requested variable, which is mass or grams. And so I'm going to use the molar mass to do that. For Ki, it's 166.00 grams per mole from the periodic table. And that leaves me with 1.30 grams of Ki. That's a pretty standard question whenever you're doing stoichiometry.